So what are we going to do in today's lecture is to continue building on top of the programs that we have wrote last time and the time before. So if you recall, we started with Hello World, a very, very simple program. And then we added, well, Hello World requires something as printf. We want to write something to the screen. But then we added a scanf, so we read something from the screen. We started with a very simple number, but then we added this inside a loop last time, where we read 10 numbers from the user to the console, and then we sum them up, and then we print this, right? And while we are doing this, we have seen few things, like for loops, for example, and then what might be a more complicated formatted output from printf, right? And we have learned about specifiers like %g, etc. So what are we going to do today is build on top of this program by adding an additional condition. So it's exactly the same program. You can use it as a starting point. But then instead of just printing all the numbers, you want to print only the odd numbers from what the user needs. Good? To be able to do this, in your opinion, what should we do? Logical, what should I do? Previously, I had a loop, a for loop, basically reading number by number, and then add it to the sum. What might be the simplest format that really I can only add the odd numbers?
Yeah. You have a loop that identifies if it's like an even or odd, and then based on that, if it's even, it doesn't add it. If it's odd, it does.
Good. Yeah. So the logic you say is correct, but didn't you saying you add a loop that determines whether did you say a loop or I guess what you make is you add some sort of condition.
Yeah.
Right? So it's not a loop. So inside that loop, you have a condition that checks whether it's odd or even, and based on this, I determine whether I add it or not. Right? Great. Thanks. And then the question is, what to do a condition in programming languages? What is the normal kind of way of doing it? Yeah. If statement, exactly. Thanks. So that means we should use an if statement that allows us to add conditions. And based on this condition, which is odd or even, I decide whether I should add or not to the sum. Now the third question is, I have an if statement and I have a condition inside it, and this condition will determine whether it's odd or even. How can I determine whether a number is odd or even? Yeah, using the modulus operation by 2, and then if it's basically divisible by 2, the modulus is, the output is 0, and that means it's even, otherwise it's odd. Thank you. So this is exactly what we're going to add to our tool today. This is just exactly goes through what you guys have said. This is what we wrote before, but then if we want to modify this works sometimes somewhat. So instead of just really having the for loop as is, I'm going to add this if statement there, and I'm going to put the sum inside it. And then, as you guys said, to determine whether it's odd or even, I do a modulus by 2. If it does not equal 0, it means it's odd. Then I do the sum. Well, what if it's not? I'm not going to do anything. So if this condition is false, I'm not going to add to the sum. I'm just going to skip to the next iteration. Right? Does this make sense? So this takes us to what is the if condition format in C. Simply, it's quite similar to any other language. We have the if reserved word, and then you have the condition in brackets. And then what is more important difference than Python is that, as we said before, every block in C has to really have those curly brackets. Right? This determines that whatever inside these brackets is in fact the code that you can execute if the condition is true. Right? In our case, it's just a single statement. One small note is that in C, in any other programming language as well, if it's a single statement, in fact, you don't need these curly brackets because there is no block of code, it's just a single statement. So if I receive these two, if I remove these two, and I only have the sum, the compiler of C will know by default that, in fact, this single statement belongs to that. So I don't know if that's clear, but what I'm saying is that if you remove these two curly brackets, it's exactly the same program in our case. Why that's the case? Because we only have a single statement inside them. So the general rule is that the compiler, if you don't have curly brackets after that, or any condition, it will always take the first statement, say that this is what belongs to that body, and then everything afterwards, no part of it. So this is the rule. The correct programming practice, though, is that in fact you should have those curly brackets no matter what. So again, like I did this differentiation before. You need to know what is the rule for the compiler for your own general knowledge, but usually there is a good programming practice that most professional programmers follow anyway, right? And part of this programming brackets is you always have these brackets open and closed for you. By the way, if you have an idea like Eclipse, it will do it automatically for you. Once you already have an F and you open a bracket, we close it for you, right? It's good for readability. It's good for making sure that you never did the mistake that you forgot to include your brackets. So it's a good programming practice to make sure you don't have unintentional bugs. Good. So this is a very simple extension. So I would say maybe you guys can try on your own. But now we are changing the program a little bit more. But before I jump, is there any question here? Does this make sense? This is white, easy delta step from what we have done last time, right? Then the third example would be, we want really to read integers, more or less the same thing, but here I don't have a number. So I'm not saying I need to read 10 or 20 or something different. I need to read integers and keep reading them until the user inputs a specific number. In our case, it's 1. So I'm using 1 as a special number to determine that the user is done. Sometimes you can really use -1, 0, it's up to you. So this 1 here is kind of convention, right? So the output message to the user is keep input integer numbers, and then if you are done, please input 1, right? And then based on this, you output the sum, right? But the sum technically shouldn't include the first one because this is your exit kind of symbol with the user, right? Any idea how to do this? And when I ask how to do this, I'm not asking really about, well, the syntax or what statements to write, but more like the logic, the flowchart, chart, right? How can I include this? Yeah. Yeah, thank you. So you said a more complicated version than what is the basic one. So the first thing you mentioned is use a while loop, right? Why that's the case? Usually for loops are good when you know the number of iterations you have, right? So for example, read 10 integers from a user. Well, I have the number 10, so I have a for loop from 0 to 9, and then it's just going to work by default. But if you have a loop that is based on a condition, in our case here, the user inputs 1, I don't have a specific number of iterations. So in this case, 4 is not really the straightforward way of thinking about loops. While, on the other hand, is the best loop you can use, right? So we'll use a while loop, but why do we even have a loop here? Because I want to repeat a certain action multiple times, right? I want to keep reading from the user until it inputs 1. So why I really should think about a loop here, right? And once you really have the while loop, your friend said, well, you have while and the condition is true, but then you have a break statement inside based on the 1. But there might be a simpler version. So the main difference between while and for is that while allows you to keep in the loop as far as the condition in the while is satisfied, right? For example, if you say while x is less than something, then keep doing this, which means every time the compiler will execute or the hardware will execute the loop, we'll check the condition again. If the condition is not violated, you continue executing the loop. If it's violated, you just exit, right? So in our case here, what should be the condition?
X is not equal.
Exactly. As far as the user is not inputting 1, I should really keep reading, right? So that's the case. And once it inputs 1, I should just really not really add to the sum. I should just print the sum direct, right? So this would be the general approach. Yeah, because again, we don't know how many integers. We cannot really. We can, in fact, if you want, use a for loop, but it's not the direct way of doing it, and we don't know how many iterations we're going to execute them. So we would have something like a while, and then if the num is not equal 1, that means this is a valid number to add to the sum, and then I will continue counting them. What do I do inside the loop? Well, you add the number to the sum, right? That's all what you want to do right now. It's a very simple program. If the number is not equal 1, just add it to your sum, right? And then after I exit the loop, I just print the sum, similar to what we have done before. Again, initialization is very important here because as we have tried in the previous lectures, if you don't initialize, well, you get whatever garbage is in the memory and then you end up with the wrong number. So let's look into how this program looks like. Well, I initialize my variables here. I have num, the one that I scanned from the user. And then I say, please input an integer 1 to quit. So this is basically the contract with the user, right? I'm telling the user that if you input 1, that means it marks the quitting of your program. So the user is aware of it. And then I scan the first number. Here I'm doing something a little bit different, a bit of a detail. So I read one number. So, and this is maybe a reason why your friend here started from the end point by saying, in fact, you should have this as true, and then you break it if it's not equal 1 from inside. The reason is, if you make a while loop dependent on the num value, well, I should at least read one value from the user, right? Because here, num is not equal 1, that means this num has a value, right? So I should ask the user to input a first number first, which is your initial condition, the very first number that the user will input. Once this is done, I go inside my loop. I check first for this first value, is it equal 1? For example, you run your program, the user, the very first number it enters is 1. Well, I'm done. The sum is 0, right? There's nothing I should do. And this is called corner case. One of the important things in programming is always think about your corner case. One of the corner cases, what is the initial condition? The second one is what is your exit condition, right? Our initial condition here is that the first number that we read from the user outside of the loop, and then if it's equal 1, that's a corner case, my sum should just be 0. But effectively, there is no num to add, right? But assuming that the number isn't equal to 1, which is the first number, I go inside the loop. What do? Well, in fact, I repeat the same thing. I first add this sum, which is for the first number, and then I ask the user, if you look into these two lines here, they are exactly the same as these two lines. But effectively, I want to do exactly the same thing. Tell the user, please input an integer, and if you enter 1, I'm done, right? And then I read it from the user. Once you hit the end, this is a loop, so you will go back, check your condition. So in the second iteration, let me one step back. In the first iteration of the loop, the num is the value that is read by the statement, correct? Right? So I read this statement, I put the num here, and this is the num value. But then I execute the loop once. It's my first iteration. And then I scan the num again. So this is the second time I read from the user, and then I go to check my condition. So in my second check, on my second iteration, the num value is in fact coming from the scanf, which happened from the previous loop, right? We'll try it out if you guys are confused. And then I check again if the inputted user value of num is not 1, I continue adding it to the sum and then ask him to enter another, ask him over here to enter another number, etc. If at any certain point the user inputs 1, what's going to happen? I will go to my condition, I check the non-equality. Well, it's violated, so I just exit, right? Well, there is something I should do here. Because in fact, if you execute this program, you never print the sum, right? So by the end of the loop, you should just print the sum. Does this make sense? By the way, this is not the only way to solve this problem, right? Your friend said a different way, and in fact, there might be multiple ways, right? But this is just one way of doing it. Is there any question? Okay, good. If that's the case, let's look into, well, complicating it a little bit more. So now, instead of reading integers, we're going to read floating point numbers. This is the first time we use something other than an integer type. And then I also want to deal differently with these values. So I want to bring them in a reverse order, right? So I keep reading. Here they are 15, so I have a certain count. I want to read 15 floating point values from the user. Once they are inputted, I want to bring them in reverse order. How can I do this? Well, previously, I needed only a single variable, right? Because every time I overwrite it with what the user inputs, and then I add it to the sum. So I only need this variable value once, right? Correct? But here, I want the 15 values because I want to bring them in reverse order, so I cannot really use a single value or single variable and keep overwriting. Does this make sense? So this is one big difference from what we had before. Is that in our previous examples, you only needed one variable to hold the immediate user input value, and then you determine, well, it's odd or even, or basically equal 1 or not equal 1 in our third example. based on a certain condition, and then you add it to the sum, and then you overwrite it, because you no longer need the old value, right? But now, I need to reverse those values in or bring them in a reverse order. So I should keep all of them. I cannot really override them. What might be the way of keeping all your 15 variables? Yeah. Yeah, thank you. So use a list or an array or any data structure. I would kind of expecting maybe the most naive thing is to say, well, define 15 floating point variables, right? True. Functionally correct, right? I can really define, well, float x1 to x15, and then read them, and then compare all of them. But is this practical? It's not practical at all, right? Because, well, instead of 15, 1/5, right? 1,500,000, right? So it's not scalable, and your logic won't be readable, and you will take a lot of time writing, right? So we need more or less a data structure that keeps all your values in a modular way, and then you reverse them. Your friend said list, because list is the most natural data structure in Python, but in C, the most natural data structure is an array, which is more or less like a list model. It's not completely a list, because a list is in fact a dynamic data structure in Python, but we're going to use arrays, which is something that is holding the values one by one. Makes sense? So we use an array to store the sequence of the values, and let's see how we can do this. So the good thing about arrays is that they are very, very similar to, as I said, to the way you use lists, although in fact they are implemented differently. But the way you use lists in Python is exactly the same as use arrays in C. So you can index them using the index. You can basically define and initialize them the same way. These are some rules, so let's just go directly to how we implement it, and then we can go through the rules together. So assume, for example, I want to define an array of 10 integers, then I would define, so I would define the type of the array to be int, and once I do this, what is the name of the array? It is called data, but then how many values do I hold inside this array? It's 10 values, right? This tells us a few things, that for example, an array cannot hold multiple data types, right? So I cannot, for example, have an array that the first element is an int, the second one is float, third one is string, etc. Your array values or your array entries, all of them must be of the same type. This is the type that you use to define the array or declare the array. Good? Then arrays in C should be defined statically. What do I mean by this? Is that the complete size of the array should be known upon declaration. So I say int data 10, that means I need to store 10 values in this array. Good? This is something different than later on we will learn in C++, or in fact it's different even than lists in Python, is that you can dynamically change their size, right? Because they are dynamic data structures. Arrays are static data structures, which means once you declare them, the complete kind of storage in the memory is going to be defined. And we'll learn more about this later on. So in fact, what happens when you write this statement is, well, again, later on we will learn that the int is 4 bytes, 32 bits. So the hardware will go to the memory, say, well, I need 4 bytes per entry. I have 10 entries. That means this statement needs a total of 40 bytes. So block 40 bytes in my memory right now and call it data, right? So you initialize, well, not initialize, you basically declare and allocate 40 bytes from your memory dedicated to this array. Good. At the end of the C part, we will learn how pointers can help us doing dynamic memory allocation. But here, this is just purely static. Well, just a very similar example, but just different types. I want this to be type double, which is floating point, double floating point, and I call it my array, and these are 100 values. Exactly the same way as before. Now, if I want to assign a certain value, a certain element in an array to a certain value, what can I say is that my array element 4, well, will hold the value of 34. So by doing this, you overwrite this entry in the array, which is entry 4, by the value 34. Good. By the way, element 4 here, index 4, is not the 4th entry in the array, it's the 5th one. Because array indices start from 0. So you have 0, 1, 2, 3, 4. So your 4A is the first element, and then you're going to store 34 into it. If you want to retrieve a certain value, well, you do something pretty similar, but you will have the array in your left side. So for example, if I want to say, just show an example here. out here. We'll have a separate lecture for arrays, but for now, if I want to write something like x equal, and then the fifth value of the array, I would say x equal my array 4, right? So you can read the value of a certain element of the array or write it. Good. So it's just a very, very basic introduction of the arrays. And by the way, what are we doing here? It seems really out of context and things are not in a specific flow. So in this first few lectures, what are we really doing? It's just giving you hands-on and very simple programs and to introduce the basic concept through this. So we have seen loops, we have seen if statements, we have seen printf and scanf, which is dealing with the console, and now we are seeing arrays. This is not covering all the details of every one of these. So, for example, it doesn't cover all the details of the arrays, doesn't cover all the details of if conditions, etc., but it gives you a hands-on, gives you familiarity with those basic building blocks of any program. And by doing them, well, you feel more confident of coding in C, and then we build on top of this expertise in coming lectures. Good? So hopefully this makes sense to you. And also kind of breaks this ice between you and C and C++. So knowing the basics of an array, without delving into too much details, let's go back to our program and see how we can really code the algorithm, right? As I advised you before delving into coding directly, you should really have a flow in your mind. Whether you write this flow as a flow chart, or you write it as a pure English or pseudocode, you should just organize your thoughts first before coding. Because when you code, you care more about syntax, right? But when you think algorithmically, you kind of think about what is the flow. And this flow can be visual, it can be really pseudocode, it can be anything. This is what we are doing here. So we're saying our algorithm in bare English is I want to create an array. I want to read those inputs, those 15 floating point values, and store them in the array one by one. And here, because I have the count static, is 15, it makes sense to use a for loop, right? So I'm giving myself a hint. And then, once I have stored them, so the user have already inputted the 15, I want to print them in a reverse order. Wow, how can I do this, right? Assume you have an array of 15 elements. You want to print them in the reverse order. What might be the simplest way of doing it? Yeah? Is there any hand? Someone else? Yeah, so yeah, please go ahead. Yeah, exactly. Thank you. So every time we started a for loop from 0 to something, which is our count, for example, when we read them, it will be from 0 to 15, less than 15. But if I want to print them in reverse order, I know that the last value inputted by the user is the last element in the array. So I want to print this first. But a for loop doesn't necessarily need to start from 0. In fact, starts from a certain initial condition that we mentioned in the last lecture. Can be 0, can be anything. So I have a for loop that goes in reverse order from 14 to basically 1, right? Also. So this is basically what is happening here. I'm asking, first of all, I'm declaring my array, defining it to be doubled with this floating point, and then the array name is A. You can name it anything. Later on, we'll learn about names, and then it would have 15 entries because I want to read 15 values. I want a variable for my counter for the loop. So I have int I. Then I ask the user to input the 15 floating point numbers. But then I start reading them from the user one by one. So inside this for loop, I want to read those 15 values. What logic I should write, what function I should use inside this for loop. How can I read those 15 values from the user? Any idea? Something we have done before multiple times. Scanf, right? So you want to read this for the user. So you use the scanf to read something from the console, right? I would have a scanf inside the for loop. Now the scanf looks a little bit different, but in fact it's almost the same. So the first difference is this specifier is no longer %d, which we have used all the way along until now. It's called LF. What is LF? It means long floating point, which is the corresponding specifier for the double variable, right? And I told you before that you can really revise all these kinds of specifiers. Well, we have a table in the lecture, and it can be referenced from any C source. But then this is because we are reading a double. Here, we mentioned before that this AND thing, we already explained it. It means I want to override this variable with the value I read from here. But now this is not really a single variable, it's an element in an array. So I'm saying A of I. You can think of A of I, so every element of the array is in fact of type double, right? So this array holds 15 values, 15 entries. Every single one of the entries is a double, right? So that means A of I is a double. And then I overwrite it with the value array. Why I'm using here A of I? Because again, I will change with the loop. I have 15 values start from 0. So the first iteration that I'm going to overwrite the first entry, the second, etc., until I reach the 15th one, right? So I want this to be variable. Then once I do this, I want to bring it in reverse order. So one way of doing it is I want a for loop, and then it goes into a certain order. Your friend already here kind of went through the order. So it says start from the maximum value, which is 14th, and then go up until 0, and then bring them one by one, right? That means the first iteration will bring A of 14, and then A of 13. Here you have an increment condition, not an increment one, which means every iteration is going to decrease I by 1. Does this make sense? So here we ended up with 2 loops. One of them is going in the normal order to read the values from the user. The other one is going in reverse order to basically bring them in reverse order.